Hello everyone. Thanks for joining this session. My name is Juan. I work at EPCC. I work in for the ARCHER2 training, organizing some courses, etc. And during these 4 days, the idea is to learn a little bit more about the data, how to manage the data using some tools as well, today we will see Open Refine. Also, we will see some. Uh, well, we will use Excel, LibreOffice, but we will not learn new features. We will use that as a tool to modify and work with some data. So today we will see Open Refine. Tomorrow and on Wednesday we will see R. And on Thursday we will see SQL. So normally, well, as an introduction, Carpentry's workshops is like a new way of teaching where the classes are very interactive. As you may know, with the now classes must be online, and we cannot lose this interaction. So my idea here using this platform, Blackboard Collaborate, is to make the class as interactive as possible. So please, if you have any questions, please feel free to write the question in the chat or raise your hand that you can unmute yourself and ask the question by voice. So yes. And also we are a small group. We are now 5 people. Well, with me 6. So it will be easier to chat and to be more interactive. Okay, so before I start, yes, that is a question saying that if these sessions are recorded, yes, we will record the sessions and upload the record to YouTube. We will send an email with the link, and you can check later the recordings. And also another thing, all the material is online, so you can check the material whenever you want. So okay, so I will share. Well, this is important. This is I didn't update that. It should be ARCHER2 code of conduct, and instead, the summary of this is please be kind. That use a welcoming and inclusive language. Be respectful of different viewpoints and experiences. Accept constructive criticism. Focus on what is best for the community, show courtesy, etc. So in a nutshell, be kind each other. And now what I will share is these slides. Well, sorry, I forgot to introduce what I will do is I will share my screen. And you know where is the material and how we will work with that. Okay, so if you go, I will paste this link in the chat. So it's there. So this is the web page of the course where the overview, target audience, requirements, etc. are written. And here we find a link that is called course materials. If we click on that link, I will close this. We go to the course materials web page. So if we scroll down, we see that for today we have at 10 data organization in spreadsheets. So if we click on that, you will see there the course material. So what I will do is I will follow this material. Also, there will be an exercise that you will collaborate uh, each other to solve it. Yes, I will explain here uh, this lesson, that is data organization spreadsheets. I will share now this. This is a small set of slides that I will also share with you later. I will paste the link. So the idea here, we will use a spreadsheet tool like Excel, LibreOffice, etc. But we will not learn new features of that tool. What we will learn here in this lesson is good data practices, because normally when we receive some data, could be from other researchers, or could be from other colleagues, or we can download that set from internet. Normally, uh, this data could be like in a could be short, could be in a good state, but sometimes could be messy. So what we will learn here is how to fix that data to make the data more readable for a person and also for a computer. As we will see tomorrow, for example, to use R, we need that the data is clear, split into columns, rows, etc. So a good way to do that is using, for example, spreadsheets. And as this is the slide said, spreadsheets are good for the data, to introduce some data, to organize the data. Uh, we can sort data, we can use some statistics, plotting, but we will not uh, see that today. So what I was saying about formatting data, when you have a set of data, for example, we will see some observations of animals. We need to put all the variables in columns. For example, date, weight, name, mm, uh, all of these, let's say, types of data should be into columns. And each observation should be in rows. For example, if you do an observation today, it should be in one row. You should use another row for other observation. And also, a good practice is don't combine multiple pieces of information in one cell. For example, you can have the date that could be 19th of October 2020, and you can have a name that could be, let's say, dog, cat, or scientific name. Please don't merge these two pieces of data in one cell. You should use different cells. Also, a good strategy, or a strategy that you should follow, is when you get some raw data, as I said, from internet or from one colleague, please don't modify that source of information. You need to keep, let's say, read only that file, and then you do a copy, and you do the modifications in a copy of that file. Because if for some reason you want to go to get the original data, you will you you will not be able to do so. So having a copy of the original data will be good. So the workflow is you get the raw data, you open you do a copy of the file, you open the file, you can do some modifications, and then to save the data, it's recommended that you use a CSV file. CSV stands for comma separate values file format. We can see later the format of this file. So what we will do now is we will do an exercise. As I see, we are now 7 people. What we will do is we can work the exercise together. So what I will do is I will paste in the chat the link because you need to download a spreadsheet. Okay. So this is what I pasted in the chat is the spreadsheet that we will work. What I will do is I will put this in my screen and we can work together. I think that I will open my spreadsheet. Okay, it's this one. I will no. Okay, so I think that you can see my screen. What I will do is I will make this a little bit bigger. So the thing is, for example, the exercise is a collaborative one, so please feel free to unmute yourself. Yeah, we will discuss about this exercise. So imagine that you receive this data. Which errors do you see regarding the formatting of that data, or which things do you think that you can improve of this source of data? What you can do, you can write your answer in the chat. Exactly. I see that, for example, one of the things that are mistake here is that there is a missing data in the white column. So here later, well, we can see it now. What is recommended is either leave the cell blank or write. There are some words you can write NA, or also you can write null. But what is recommended is that you leave that observation in blank. Because, for example, if you write 0, you don't know if 0 is the observation or it means that the data is missing. You don't have that info. So the recommendation is to leave that the observation. If you don't have that value, leave it null. Also, another mistake is here that, for example, in weight, We have 132, 113, but they said scale not calibrated. Here, what we are doing is we are merging two different data. We are merging the weight, and we are merging the if the scale is calibrated or not. One possibility to avoid this is to create a new column. That, for example, here you can write uh, calibrated, and you can, for example, say no, no, and here say yes. And for example, in that way, you can uh, you can make the table much better. And also, well, if you see here there is a typo, so also it would be more difficult. It's like more elegant to use yes, no, or you can use well, you can use 1 and 0, but it's maybe could be more confusing for. But yeah, yes, no is fine, and then you can edit this column, the 32 and 113. Exactly. This is another thing that can be improved. If you see here in weight in this column, uh, we see numbers, but we don't have the um, it's not included that is grams. So mm, uh, software like well, like Excel or R or Python, etc. We will not recognize it as a number because that is a G. So that is a character, and they cannot recognize that data has a number. So what is recommended here is not to put the scale of that data. So just introduce the number. For example, here we will need to write 33, 40, and so on. So remove the unit here. So remove the G. Do you see any other problems with this spreadsheet? We have seen so far three, but there are more problems. Yeah, there is a question saying, is there a way to remove the G other than typing everything again? Uh, yes, there should be. What we will see later is with OpenRefine we can modify. We can do modifications in the data in batch mode. It means that we can modify like a whole column of data. For using Excel or LibreOffice should be a way, but I should check that later. And yeah, later I will explain. I will find the solution because yeah, now I cannot see an easy way to do that. And also there is another question is do we know that the units for weight are the same across each species? That's also the uh, a data that, for example, that we don't know. We the way of doing this is either add the information here in the column header saying like this is grams, and also recommended practice to do that is normally all of these files should be with a README file, and this README file should explain that, for example, the weight is measured in grams or any other unit. But yes, at first glance, we cannot see if we can assume that all the weight is in grams, but yeah, we are not certain. Should be like explaining a README file that should be like with the well with the raw data. Okay, so for example, other problems that I see here is if you see there is a table for the species called DM, there is another table that is called DO, and there is another table that is called DS. This because we will see at the end of this lesson that we need to when we export this to a CSV file, it will be a mess too, because having several tables is not the best way to be organized. So what is one solution is to merge these three tables and create a new column called the column could be called species. Make this bigger. And for example, here, okay, we have a DM, so we can make all of them DM and copy this data here, and instead of here we introduce DO. So what I do to yeah, I copy this cell and I select the rest of the cells, and you can see that. And we can do the same with this table. And if you see like we needed to like move that. You see that it's better to have like one table, because for the to use software, other software, it will understand better the table formatting. So another mistake here is if you see at the bottom, you see that there is 2013, 2014. If we click, well, you see that the format is different. Also, we have another tab that is called dates. The recommendation is to use one tab. And if you use more than one, it should be for a strong reason. No, for example, to have observations divided by years is not. I don't find that is a strong reason. For example, now that we see this table 2014, okay, this is like a small. Another mistake that you can spot here is regarding the date. Here date, you see that the format is okay, 8th of January of 2014. So we have a day, month, and year. But for example, in plot 3, we have a day and month, but we don't know the year. Okay, we know that we are in the tab 2014, but that year is not here. So when we use a script, for the computer will be impossible to know which year is in which year was taken the observation. So this is important that the dates should be like should follow all of them in the same format. A recommended format could be use text and use, for example, year, month, and day, or also you can use other form. Some people, what they do is they divide the column date into three. They generate a column that is a year, a column that is a month, and a column that is a day. And in that case, you don't have this problem with different data formats. So you have like different choices. Also, for example, here you see that these two cells are in gray color, and they said the gray cell means my measurement device wasn't calibrated correctly. So another mistake is mm, using formatting to give some information about the data. Because imagine that you open this with another program or with another tool, and this color is removed, so you don't know if the data was, if the measurement was good or not. So you need here to add, for example, what we have done before. We can add a column here called calibrated. Make this bigger. And here we can say no and no. And in the rest we can say yes. So this is important. Also, the danger of using different tables is, for example, you see here that you use date collected, species, sex, weight. So it's you see, you can understand what the contains. But here you use WGT. Okay, we have seen other tables, and we can maybe we can understand that is weight, but we don't. If other person can see that word, they cannot understand what is the column about. So do you have any questions on or concerns regarding this, or do you spot other errors that it can contain? If not, what we can do is we will go through the list all of these mistakes, and we'll see if we have a spot all of them. What I will do now is I will share my. Okay, I have a question here that said, would it be better to use year, month, day format? Yes. So this one of the ways to manage the dates is to use some people, what they do, they use a string format, and what they bring is for example, today's 2020 is the year, the month is 10 is October, and the day is we are 19th. So 19, yeah. So they use that format. Also, instead of that, you can use bars. The important thing here is to use a format that is readable by a person and also readable by a computer. Because a computer understand that this first bit is the year, the second bit is the month, and the third bit is the day. Other people, what they do is they write, I will make this bigger. They will write, for example, year, Don't know why it's saying. They write a year, month, and day. I will make this bigger. And for example, they write in year 2020, in month 10, and in day 19. Sorry, this spreadsheet is a little bit of a mess. That is, yeah, now it's more or less the same. So there are two ways, or either use a string to write the date, or separate the data by columns. You can choose. Okay, I see that there are no more questions. I will what I will do is I will share my the slides. Okay, so this is the common mistakes that we can have in a data source. This is like the recommended way to. The first one is avoid using multiple tables in one spreadsheet, because we will see later that when we export this data to a CSV file, we will get some errors. Also, another recommendation is avoid spreading data across multiple tabs. I think, let's see if I can. Okay, we have seen this one. Now, multiple tabs. Also, well, they said here record zeros as zeros. For example, for the um, because for in the spreadsheet that we have seen before, we have seen that there is a blank space. But what some people what they can do is, for example, if the weight is 0, there's maybe this is not the best example, but in other examples, if the weight is 0, you should record that. You should use a 0, because otherwise you don't know if the data is missing or if the recording is 0, so you should be explicit regarding that. And this is what they said: use an appropriate null value to record missing data. Also, don't use formatting to say that if, for example, in our case, if the weight is calibrated or not. If you have a comment, use a separate column. Or also, what I will recommend is write this comment in a README file. Also, this was the first question that was asked. Record the units in the column headers rather than in the cells where the data is. Also, include only one piece of information in a cell, and avoid in the cell avoid the spaces, numbers, special characters, because then to work with the data will be not the best. Yeah, this is like avoid avoid the special characters, and what we have said before, for the metadata, use a separate plain text file to say that, for example, this data is from Australia, taken during 2013, 14, and 15. The description of the data and some details of the data is better to include that in a separate plain text file. What I will do is I will share. We'll go through the content to see if I have missed something to explain, and also I will you will see where I'm taking this from. Okay, we'll share screen. Okay, I think it's the one. Yes. So this is what I said before. This is the course material. What we have seen is here is here, for example, we see an example that is we have one table that everything is in that table. We have a date collected, year, month, day. For example, here they use for the date they use 3 different columns. Also, well, you can have a plot, species, sex, weight, etc. And also in a different file we have some notes. And also one thing that they are doing here is when you take the data, the raw data, and you do some modifications, they write the steps that they have done. Is for example, they write in the, if you see in 2013 clear, they create a species column and move information from header to that column. So also is a good practice when you modify some raw data to write the steps that you have followed in order to make your study reproducible by other person. Normally this is done when you publish a paper or for your colleagues, for example, if they want to work with that they want to work with that data, they can or for example imagine that we are getting this from 2013, 14, and imagine that there is a new set available on internet that is from 2015. You download that set and you can follow you can follow the same steps that you have done for the other sets with this new set. This is what I explained before, that you use columns for variables and rows for observations. So here is explained the common spreadsheet errors that you can find, and this is what we have seen before. That is, for example, the use of multiple tables. This is not a best practice. It's not a recommended use multiple tabs. Also, this is like not filling zeros, so means that, for example, if the data is missing, don't write a zero, because the computer could understand that the zero is a valid number, or is not something that is missing. Also here, for using problematic new values, you can find, we'll make this bigger. You can find a table where the new values that the ones that should be avoided and the ones that are good option, best option, etc. For example, here we see that the best option is have a blank, because this is compatible with R, SQL, Python. You can get the data and you can work with the data using scripts. See what we have seen before. No, don't use a format to say that the measurement device is not calibrated. Or use formatting, place comments in the cell. You should use another file. Introduce more than one piece of information in a cell, or also the naming of the columns. Write a name that is readable, and try not to use special characters, or for example, if it's for the weight, don't use if you use W, other person cannot understand what the data is about. Inclusion of yeah, metadata is what I said before. Please use a file to and here what we see is yeah, I have explained this before. Normally is what is preferred is to use year, month, and day, uh, uh, something like this, to write the date. You can use that, or you can use another way is to use year, month, and day. That is another option, but to be honest, I haven't seen this too many times, that you can write year and day of the year. But I will yeah, I will use either 3 columns for the date, or use the format, for example, let's say year, month, day. The important thing is to use like a common format, and also explain the format. For example, the the text file to explain, okay, all the data is all the dates are in format year, month, day. If you add something, please use the same format. Okay, here what we see is the quality assurance. What I will do is I will share. Um, let me open I will open Excel. Mm, and we will see how we can do that. By the way, do you have any questions? Please feel free to ask anytime if you have any questions. Okay, so I will share. I have a question that is there a way to a best way of creating a README file? Uh, Normally, for example, for this, what I will use a text file rather than, for example, use um, Word or any other tool that is like a more complicated. I mean, if you use a text file, you can open this file with more software that if you use a specific format, like a doc for Word or any other tool. That is some for the yes, I will use plain text. It will be my recommendation. Also, you can use there is some to format this text. That is I don't know if you heard about Markdown. That if you use a repository like GitHub, for example, and you upload that text file, you can introduce some formatting. And also in the text, you can see the format. If, for example, there is an asterisk, and star could be a point in a list. There are ways, but yeah, my recommendation would be to use plain text. Is the to use the easy way of doing that. Okay, so I think I didn't share my screen with the that. Yes, I see that you can see the. Oh, well, I need to. So yeah, what I'm here is I'm using Excel. This is the online version, but you can use LibreOffice or you can use uh, what I will explain here. You can do this in using both programs. We can do that now. What I will explain here are two things. One thing is the conditional formatting. That is, for example, for the weight here, if you select the column and you click in conditional form, I'm not sure I will make this because I think the text is quite small. Okay, it's making bigger the data rather than, well, the button here said conditional formatting. If you click here, you can use color scales. For example, let's use this one. And for example, using that, you can see that when for the weight, if the weight is low, is in red. So we see that 33, 31 are low. If it's like, say, close to the average is yellow, of you can see in green that is 52, 50, 48. Well, this is when you want to see understand some data, but you shouldn't use that to because I mean we have said before that you cannot use you shouldn't use formatting to uh, to save some data, or not to save some data to save some conclusions about the data. But this is you can use this for you to see if something is to spot if something is wrong or not. If maybe you can see that the weight 31 doesn't make any sense. This is a tool for yourself to see if something is wrong. So we have the conditional formatting. Also, that here there are many ways of because you can imagine that is instead of working with data regarding species, etc., we are working with money. You want to highlight when you receive some money or when you have to pay something. So also you can say if the value is positive, please put green. If not, is put it in red. Or you can also choose the colors, or you can for persons that are because yeah, could be a color blind. They can you can use a different format that they can see. But this is I insist this is for you to see the data and make your life easy to spot if there is a mistake with the data that has been collected. Also, a way recommendation for the spreadsheet, you can do that. Or if you use the spreadsheet to introduce some values, you can use you can validate the data. that here, if you are in Excel, if you click in the Data tab, there is a button called Data Validation. So here, if you click, can you? I see the. Can you see the screen? I see that is the font is very small. Sorry about that. Okay, what I will do is I will explain everything that I'm doing, and then you can later you can do this with your either with Excel, OpenOffice, etc. So here settings, for example, now currently this cell set any value, but we can say that no. Yes, yeah, it's a very small. The thing is, yeah, I will explain everything that I'm doing, and then you can do it in your own. If you have any questions, you can ask tomorrow, or we will have a consultancy drop-in session 1 month after this, and you can ask. So here, what we will say is what we will allow is only numbers. Only numbers. Imagine that the number will be allowed between, well, the sample that is in the text is between 1, that is the minimum, and in the maximum we put 24. And also that is we can introduce here a message. There is here error alert, a message, and the message could say the value should be between 1 and 24. Sorry, 24. Okay. Also, the text is very small for me as well, and I cannot see the. So, for example, if we click OK, here we have said that we can only introduce a number between 1 and 24. So if we introduce 1, yeah, it works. But imagine that, okay, we want to introduce 28. So here we got a message that the message said, well, what I have written before. The value should be between 1 and 24. And you can retry. Okay, so if it should be, let's say, 23. And it works. So we have seen two things. Conditional formatting that makes easier for you to spot if there is a mistake or something that is not right, and also data validation. For example, if the weight should be positive, so you can also put that option in your spreadsheet. We have seen this using Excel. Also, we have the same features if we use LibreOffice. I will share that window. Hope that the text is bigger in the still quite small, but for example, here for weight, we can use if we go to thing is washing. Okay, no, I don't remember what was the. Well, what I find here is for the conditional formatting. If we select this and we click here that says conditional formatting, we click in core scale. Well, you see a similar you see that the 33 and 31 are in red. The ones that are, let's say, close to the average are in yellow, and the bigger weights are in green. The validation, I'm not sure if it's here data. Okay, is here, but the problem is you cannot. Okay, you cannot see the window. What I will do is I will share. Oops, these are the whole. Mm, 1 second. Okay, the problem is I cannot share my screen, but maybe I can share. Yeah, these are the things that are like more challenging when you are teaching online, that you cannot show. Sorry about that. Okay, what I said is when, for example, here you click in data, there is an option that is called validity. When I see click on data, is in the menu that we have here on top. I don't know if you can see the pointer. Here in data, there is an option called validity. There is a window that gets open, and you can do the same modifications. You can say that the weight should be between 1 and 24, could not be a negative number, etc. So what I have explained now, I will okay. I will share another. Okay, now you can see well, here is explained okay, here you see a bigger so here by default you have in data validation, you have any value, but what we want is we want whole number between 1 and 24. And if someone that is using this someone that is using the spreadsheet to introduce some data uh, makes the data like less more accurate, because they cannot introduce data that is wrong. And also, yeah, in the message you should write valid plot ID are the numbers 1 through 24. Also, a way that is explained here is shorting. You can short the column, and you see, for example, if there are negative values, that you should remove them, or you can use conditional formatting. That this is what we have seen before. The idea of this is where the first one is to avoid the data that is wrong, and the second one is to spot data that is wrong, and maybe you need to get rid of that data. Oh, okay. I need to use one last thing about once that we are happy with our data, we need to export the data to a CSV file, because if we want to use think tomorrow we will see with R that we will use a CSV file. We need to save that data into that format. Here is explained how this is done, but what we will I will try to share my screen. I will share my screen and explain how this is done. What I will do, okay, I will share the other window. Yes, so you can see. So what I will do is, mm, the problem is with this spreadsheet that they a little bit of a mess. So what I will do is I will copy this part. I will use a new tab. And I will copy that data here. This is because the column should be bigger. So now what we will do is we can, yeah, the problem is when I click on file, you don't see the menu that is at the bottom. But for example, with this program, you can use file, export. Also, yeah, you cannot see the window and you can select the format. What we will do is, okay, we will see you can do this later. We will see here, yeah, you can see normally the way, if you use Excel, LibreOffice, etc., is you use save as, and you choose the name, and in format you need to use CSV, that is comma separated values. And when you select that, you select that format, and then you click on save, and in that way you save the data in that format that can be used by, for example, no, SQL, R, Python, etc. Also here it is explaining that sometimes you can find here what is explained is that sometimes you can save the data that because if you use Windows, the end of the line, the character that you cannot see is hidden, is different that, for example, when you use Linux. Sometimes when you open a file, a CSV file that was generated using Linux, when you open this using Windows, you can see uh, everything in the same line rather than separated by, you don't see any breaks. So here what is explained, I will not get into that, is ways to save CSV file that is compatible with Windows and in general with all of these operating systems. And also there are some tools that can change if imagine that you get some data that is that was saved in Linux, you can use, there are tools that you can change that file in order that this file is open using Windows. So yes, this is what I plan to talk about the data, yeah, the data organization in spreadsheets. Do you have Any question? Okay, what I will do is I will share the. Okay, if you don't have any questions, what we will do is well, we have a schedule our morning break at 11:15, so in 5 minutes. But we will start. Okay, we will start with the break now. So what we will have is a 20-minute break, and then we will start working with Open Refine for data cleaning. Well, so yes, this is Open Refine. That is maybe because the thing normally is you see when it's a face-to-face, there is a big screen where you can see what everything that they do with the screen, and you have your own screen where you can do where you can do the things with the Open Refine. Here is different. If you have one screen, maybe it's quite difficult to follow what I'm doing and then use your Open Refine screen to replicate the steps. If you have two screens, yeah, it could be possible, but if you have two screens, yeah, it could be possible. But what I will do is I will explain the concepts of Open Refine, and we will go through some exercises, and then you can play with it. As I said, this will be recorded, so you can check the recording anytime you want. And you can pause, stop, start again, etc. And also the material is available online, so you can follow also that material. So yeah, thank you for your answers. So I see that was not any problem with the installation. If case that yes something doesn't work later, etc., please let me know. I will be if yeah, I will be in touch and help you as much as I can. Cool. So well, there are two steps to do the. Well, first, I think okay, I need to share again the. Okay, I will share the screen with the material that is. I will do. I will paste the link in the chat of the material in case that. Actually, I will share. So it's quite slow, like sharing the different windows. It's not the best. So, well, okay, I will go back. This link is here. If we are in the schedule, you have that 11:30, yes, Open Refine for data cleaning. We click that link, and here we have the lesson that we will see now. In setup, well, they explain how to install Open Refine using Windows, Mac, or Linux. And also we will work with this file that I will copy and paste in the chat. Okay, now it's in the. So this is the file that we will work with. And you will see that is a CSV file, the file format that we have seen before. Also, what we can do, I will, 1 second, I will try to open that file and you can see, or well, you can open that file and see how it looks. Oh no, it's using, no, I don't want to. Okay, if you open that file, what I can do is I can share my, oops, I will share my screen. Sorry, I see the font is very small. I'm not sure. Yeah. Uh, if you open the file, you will see that the first row of the CSV file is the column names, the names of the column that is survey ID, record ID, month, year, period, etc. And then each row is that data separated by commas. That's why the name is CSV, is comma separated values. So what we will do is we will import this file into OpenRefine. So let's share OpenRefine now. Great. So here they ask we will create a project, and they ask this compute get data from this computer. So we choose files. Okay, you don't see the, yeah, that's a mistake. You don't see the, when you click choose files, you get a screen where you can click on the file that you want to import. So I go to the folder where the file is, and I click in open. And now you can see that the name of the file. So we click on next. Also, please, if you see that I'm going through this material like quite fast, quite slow, please let me know, and I can be faster or slower. I can adapt. Okay, my screen is quite big, so I will make it smaller. Okay, I think it's better. Can you see the screen? I hope that the font is. I think, yeah, could be a little bit small, but it's okay. You see that, for example, on top we have the column names: survey ID, record ID, month, day of the year, period, plot ID, etc. So here you have the column names, and then cool, thank you. And then yes, I will make this a little bit bigger. Is that better? Yes, the thing is the problem is I cannot make this bigger because to see all of these options could appear a little bit um, in in places that were not in bad places. So what I will do is later that when we see the data, I can make the screen bigger in case that. But I hope it's okay for now. Uh, I mean, the important thing here is once that you import the CSV file, you should see that the import makes sense. For example, we see that the months are numbers, year is, yeah, 82, etc. You see that the columns names are okay, scientific name. We see that more or less it's the data makes sense. So I mean the preview makes sense. And also here you have a lot of choices that normally you click on. Well, you can change the here. You can change the project name. That you can choose any name that you want. I will think, yeah, I will leave this like that. And then here there is an option that is trim leading and trailing white space for strings. And what we will do, because otherwise, well, this is set on by default. And this is a good practice because it will make the data more cleaner. But for some exercises, we will switch it off. Well, the preview is they are updating the preview, and yeah, you can see that. Well, this is like we can see the mistake here that, for example, this scientific name contains two space characters at the beginning. So it will make some errors when we manage the data, but we will solve that later. Okay, remember, previous versions of this tool didn't have this at the beginning, so now it is a good way to click on that. But well, okay, now if we click and create the project, oops, see that my memory usage is almost full. What I will do is will close some, I will close this window. Yeah, this is a, okay, maybe because this is, okay, I hope that my memory consumption is better now. What I didn't say, sorry about that, is what is OpenRefine about. OpenRefine is the idea of OpenRefine is you get some data and you want to clean that data. So this is not like Excel or LibreOffice Calc that you get the data, you can do some formatting, some things, etc. Here, what you do is you clean the data, you can work with the data, you can filter the data, etc. And once that you have done that, you can save that copy of the data. So this is what I mentioned before, that is good to have the original data original, don't modify that. You can save a copy with the data that is clean. And also the good idea, what we will see later, that we can save the steps of that we have done. Like for example, remove spaces, sort by, or let's say sort by name, etc. You can save the steps that we have done so far. So yes, let's start. We see that what we have done. We have created the project, and now what we will work is with the faceting. What's that? Is you can select parts of the data using that tool. So how it works? What I will do is, well, let's for example, here in a scientific name, you see that there is an arrow here. So if we click on that, we have a lot of options that I will check if you can see this. Great. Okay, because I'm sharing the, yeah, you can see the options. Great. So we click here in facet, and we click in text. And now you see here on in a column that is on the left hand side of the window, you see for example, the scientific names. You see that all the scientific names that are short by name, and also if you click here, you can sort them by count. And for example, if there is a question, what is the scientific name that appears most in that data set? You click here, and you see that the one that is most repeated is Dipodomys merriami. I'm not sure about the pronunciation of that. And you can work on that, and also you can, if you want only this scientific name, if you click in include, you see that you have selected these matching rows that are the 1596. Well, if we click in this, we select again the whole data set. We have different facets. We have a numeric, timeline, etc. We will see them later. And for example, there is we can have there are some exercises that one of them is using faceting, find out how many years are represented in the census. So the way to do that, as you can imagine, is if we go to the column, this column that is a year, we can click on facet, test facet. So if we click on that, we can see here all the years. We see that, well, these are sorted by name, so we see that the range is from 1977 until 2002. And also we see that this should appear quite small in the screen. We see here in a gray color the count, the number of. So for example, if there is a question, which year has the most number of records, we can click here in count. And we see that the year 1997 have more than 2,000 counts, more than 2,000 entries. Also, there is another, because this is what they said, that, for example, we can find that some data is not short, or they contain some mistakes. When you see here scientific name, you can spot that, for example, these three species has a similar name, but one of them is spelled in a way, another species are spelled in a different way. So one way to spot that and one way to work on that is this is called clustering. And how the clustering is done? So the way of doing some clustering is if you go again to scientific name, the arrow that is on the left of the name, and you find here no, sorry, it's not here. If we see, sorry, in the facet that is here, we see that there is a button that is called cluster. So let's click on that. Check that you can see yes. So for example, you can choose the method that could be a key collision. This is what I mean. This course is an introductory course. This tool has so many options. So if you want to investigate this further, you can go to the documentation. For example, here, if I click in find out more, you can see the more documentation about that. So what well, in the material, in the course material, is that we need to choose. And here we find that, for example, we find three. The first case, we find that there are 5 species that the name is quite similar. So if we can check that these 5 names are similar, or are the same. So what we can do is we can merge these. We can merge all of the values and select this one by default. So I think we can. Yes, we can. Let's do that. So if we click in merge, and then if we go, because okay, my window is a little bit, I will make it a little bit smaller. Here in the bottom, you can see merge selected and recluster. Or well, merge selected and close. Let's click in that and merge selected and close. Well, we get a message that mass edit 300 cells in column scientific name had been done. Also, this notice that here, please note that here we haven't changed the original data. All of these changes must be saved later. If now we click in, we have here a phase set filter tab. If we click in undo redo, we see here the steps that we have done. That, for example, here we see that we have modified the data. Well, modify the data. Yeah, the data that is in the project, doing this mass edit of 300 cells in column scientific name. What we can do with that, for example, if we see that we are not convinced of the results that we have got, we can undo this step. If we click in here in this in zero, create project, I click, but yeah, my computer is getting a little bit slow. I think I have too many windows open. It will get to the original view that we had before. Okay, now it works. So now here we have let's say the original data. We removed this. We have removed this clustering. Also, another way to okay, we can cluster the different entries, and also if we have a column, we can do so. We can split the column, because imagine that talking about again about you see that all these scientific names are composed. You have like a first part and second part. So if you want, we can we can split this column into 2 columns. What is the way to do so? We click on scientific name, and we click in edit column, and there is here the option split into several columns. If we click on that, we see that we will the column by separators. So instead of a comma, we will use a space, and we will unselect this option that is remove this column. if you click on, if you leave this clicked, the original column will disappear. So okay, split by space. We're clicking on OK. Yeah, so working on that. And there you see the message that is the column has to be split into this. And you see, for example, here in undo redo the same message. So you see the step that you have done with the data. What is the problem that we spot here? It should be two columns, right? The first, I will make this a little bit bigger. You see the scientific name, that is yeah, first part, second part, and exactly, for example, here we see the first part of the scientific name, and then we see the second part of the scientific name. What is the problem that we get here, for example, for these two first entries? Do you remember before that we unselect the option of trim of remove the spaces between remove the blank spaces in the cells? So we get this problem that for these two entries, we have two spaces at the beginning, and when we split the column, we get this separation that is not good. A way to solving that, as I said, we can remove the change that we have done. So if we click here in Create Project, okay, we get the original data. So there is an option here in scientific name that is, let me see if I find the, exactly, click Edit Cells, Common Transforms, and here you see the same option that we have done, we have seen before. That is trim leading and trailing white spaces. So if we click on that, they said that three cells have been modified, and then we can split the cell again. So if we click the arrow scientific name, edit column, not cell, split into several columns. Again, we repeat, the separator will be a space. We don't want to remove this column, or if we want, so please be aware that this you have this choice. Okay, and now you see that the split was done correctly. You see the scientific name, well, is 1 or 2, but you can also you can rename, sorry, not remain, rename that these columns. So do you have okay, leave some time if please, if you have any questions regarding what we have seen until now, yeah, please feel free to ask. What we have seen until now is phase setting that we see here. For example, by year, we see all of the different years that we have. We see the count. We can understand better the data, or we can do some queries. For example, what we have seen before. What is the year that has more entries? 97. The year that has less, 1977, etc. And we have also seen clustering. That is when you have, like in this case, similar names, you can choose the right one and change all of these names and get a common one. You can split the column into different scientific names, etc. And also we can remove white spaces in the columns, and we can undo, redo, etc. Here you see the things that we have done until now. Okay, I think that we have a few questions. Oh, yeah, well, the question is that there was like a mistake with there is a with a valid JSON string that it mm, yeah, it depends. Is I think because here this set is a little bit because the set, if you see here, you have like a JSON information, so maybe the error that you get is regarding this info. I mean, normally the data sets that work, you get either numbers, text, etc. But yeah, having a JSON code inside. No. Okay, I see that. No, okay, that was in the. Yeah, I have seen this error a few times, but yeah, I have seen this error before that when you undo this an operation, yeah, when you undo this operation, you get a message of this. But for example, if, when you click when you click back and you click on cancel, is that okay? Or you see, for example, if I do that, okay, you get this error. But if you do cancel, uh, I mean the state is similar like this. Not sure. What we can do is I can yeah I can check later the error and I can give you a solution. But yeah, it's a common error. I have seen this before. I'm not sure if it's because of the browser, because you can use Google Chrome or you can use Mozilla Firefox or well Internet Explorer, or could be the browser operating system of the Open Refined version. We can have a look at that later. But yes, it's a common mistake that. So yeah, what we will do is we will continue seeing more features of this Open Refine of this tool. And what we can do is well, what is next? What is next is the filtering that we have done this before, because here we have well, you see that you have 35,000 rows, and you can do some filtering in case that you want to see some data for a certain year. So for example, here if we go, okay, we are now in the year phase set. If we sort by count and we click in the list one, let's say 1977, if we click on that, you see that now it appears in red color, and instead of having well, we have a total of more than 35,000 rows. Now we have 503 rows, and you can see, well, you see that the year is for all of them 77, and you can go through the data. Also, you can change here. So now I see 10 rows, but I can click and I can see 50, for example, if I click here. see 50, and also you can go because only shows 50 rows. If you click on next, you can see the other ones. Also, if you click here is to go back to the previous, I think if you click again in the 1977, you get the uh, original table with all of this data, or you see that there is something here that you can click on what is quite small. This said include. Yeah, take some time, and then exclude, and you get again the whole set. Also, what you can do is you can sort the data. Let's sort, for example, by well, here, for example, in well, we can sort by, let's use we can sort by scientific name. If we click here in this arrow, we get the window. Well, we get an option that is called sort, and we can sort by text, numbers, dates, etc. Here in this case, I will sort by text. And also here, this is nice that you see position blanks and errors, and you can move. Well, the current order is first. You will see valid values. Then you will see errors. Errors could be, for example, if you sort by number and there is a cell that contains some text, you will get an error. Or well, they will show you as an error. And also you can see blanks in case that, for example, we have seen before that for weight, some blanks could appear, or imagine that a column that is mandatory that no blanks, I mean, no blanks are allowed. You can see then by changing this, you click and you drag at the top, and you can see in first position blanks. Let's see if they contains any blanks. Seems okay. Sorry. Yeah, this is what I said. Here you see that there are a lot of blanks that yeah, we if the data is not if this piece of information is not mandatory, that's fine. But in case that, for example, a blank is not allowed in a column, you can, for example, filter and remove blanks. You can do all of these choices. Or, for example, for the study that you plan, you can if the records that contain blanks are not important for your study, you can remove them. So also if we can do well reverse sort or remove if we know that okay we have some blanks etc. and we are not interested anymore in the sort, we can remove it. We click on that, we'll see that we will get back to the previous view. We can do another sort, but this, yeah, having valid values in the first place. And you will see now that the view will change. Exactly. We will see first these ones. And again, we can remove the sorting. And also you can sort different columns. For example, if we want to sort here, in this case, we have a year, month, and day. So we can sort by this. So okay, let's start. Let's sort first by first by we can sort by year first. So if we click sort, we can say numbers as small as first. So we click OK, and we will see now that the first are the year 77. Now we can sort by month. We click on sort. We click sort cell values as numbers, smallest first. And then we can sort by day of the. We click in sort, numbers, smaller first. And we can see that we can get the date sort by, we see that this here we have a 16 of July of 77. Now we have 17 of July of 77. And then once that you are done with that, you can remove the sorts by clicking in the row sort, remove a sort. And for the year is the same, sort, remove sort. And you get rid of these sorts. So when you do this filtering and when you do this sorting, you are not modifying the original data. You are modifying the view that you have of this data. So this is an important point that to make. Also, another feature that I would like to discuss is about the data for numbers that you can see that we have Open Refine by default treats or handles everything that is the default format is text, but we can use numbers. For example, we have this column, the column period. We can modify that column and make it a number. The way to do that, if we click here in this arrow, edit cells, common transforms. For example, for text, you can modify to title case, uppercase, lowercase, etc. But we are interested to modify that have a number. So common transforms, edit cells, common transforms to number. So now we see this message here, and you see that the color, or where you may see that the color instead of be black, now is dark green. And also if we click in this tab and do redo, we see that we have a text transform. So far we have three operations done. We remove spaces, we have split the cells, and we have transformed this column to a number. And now, having this as a number, we can use facet. We can use a numeric facet. The difference is the what we will see now. Here in period, not sure I will make this. Will make this bigger. When we have this numeric phase set, you see that we can select a range. For example, let's select from 0 to 300, and you can use you can do it graphically rather than clicking on the. So you see that these rows are well the matching rows that from 0 to 300 are 33 and a bit thousand rather than 35,000. So you have this feature instead of using a text facet, you can use a numeric facet that looks in the in that way. In the documentation, is explained that there is another one that is the you click here facet, that is the scatter plot facet, but I don't know why where some people can have this error that they don't get the I cannot see the picture. If I use that, you see that I get a blank picture. Maybe if you try that, you can see something different. But yeah, sorry that I cannot show this now. And okay, what else? Yeah, okay, make this bigger. The what I explained, the idea of also the feature and the good thing of using OpenRefine is that you can reproduce these steps with you can reproduce these steps with other data sets that have the same format. Because if you click here in undo a redo, you can see the steps that we have done so far. So what I will do is imagine that we want to save these steps and apply to a different data set. I will do that, and you can see the if we click in that button here that is called extract, you can see the mm, JSON code, and here is explained the operation that has been done, etc. You don't need to. Well, you can read through the text, but you don't need to understand everything there. You see that this is like the operations that we have done are saved in JSON format. Maybe for some of you that get this error with the JSON, maybe you don't see that. So what I will suggest is, yeah, if you follow my screen, and we will work this through together. Also, you can select the parts that you want to save or not. For example, if we want to remove this split column scientific name by separator, you can click that. So what we do with this is we select everything and we copy the text. And what we okay, I will do that. You will not see my screen. I will open a text editor and I will save this Why this is important? Because, for example, when you publish a paper or when you save some work for future colleagues or future reference, you can say, okay, I got this data set and I apply these operations, and you have this text file, and another person in 1 year time, or even yourself, after a year that maybe you don't remember what you have done with the data in order to make a cleaner version, you can check these steps. So, okay, I copy this. What I will do is I will create a new project. So you will see again that I get the create project window. I will choose the file that I will choose the original, the file that we worked before. Next. Okay, I will rename this. I will this my project is not the most original name, but what will work. My project. Okay, I will leave this. Well, no, will remove this. Trim leading now, and I will create the project. Yeah, I'm running out of RAM memory. And okay, I will make this smaller. We see that we have the original data without any. If we click on the redo, we don't have anything here. So it's like we come to the beginning of the. Okay, we make this bigger. But okay, if I want to reproduce the steps that I have done with the previous file of the previous project, if I click in apply, they say paste and extracted the JSON history of operations to perform. So I will go to my text editor, I will copy the operations, and I will paste them here. I will make the window smaller that you can see and now you see we can click in perform operations working. And you see that the operations has been done to this project, this column, yeah, my project. We will see that the two columns are divided. Sorry, the column scientific name has been divided into two new columns. We will see also that the period is the color is dark green, so that means that this was a number. What we miss is the face set filters, but well, we can. This is not. This is only to visualize the data. Is doesn't is are not related to the data cleaning. So doing this makes let's say, science makes the cleaning much more reproducible. In order that, for example, if you are in the research and you want to publish a paper, another person can replicate your steps. And also for your company, it's quite important that to have the documentation where company, university, research center, etc. That because it happens to me a lot sometimes where I work that I'm in a project and sometimes I had to move to another project and another person comes to the project and needs to uh, take over my continue my work. So if I give this okay, I use this data set, I use this set of steps for the person who is taking over my work will be much easier that if I say, okay, I select this column, if I'm like more vague regarding details to cleaning the data. And two more things regarding this tool. We can save this new project, if there is a button here on top that is called export, so we can export the. Actually, there are two things. We can export the Open Refine project, so we will save the steps that we have done, or we will save phase, etc. So if we click here, yeah, I'm not sure it's to. Okay. It's what you see in the bottom of my window that this like a download to you download this my project dot tar dot g. You download a compressed file. So you can click. Well, you don't see the options here in my screen. They said open, showing folder, etc. And then you can move that file to another. But also what you can do is export. You can save this in comma separated values. There is another choice that is a tab separate value, but well, I prefer comma separate values, or well, you can use you can save this in Excel in a open format. You have here different choices. And to finish, I will change my change the screen that I'm sharing. Let's see if I can. Okay, I need to. Well, actually, I will open. I think maybe it's easier if I do this. This is the last part of the. Now here is the documentation about on-page refine. This is what I said. What I have done here is just an overview of the tool. But here you can find the website, documentation for users, the open. There is an open refine book, the history in the Wikipedia. Here you have like more resources for the about open refine. So, do you have any questions regarding this tool? Yeah, that's exactly that. What we have seen so far, yeah, maybe it doesn't generate not too many questions, but yeah, the idea is that the idea of this is that you check the tool, you work with the tool, and if you have questions in 1 month time, we will have a drop-in session that where you can ask these questions. And also, for example, if you check this afternoon and tomorrow you have some questions, so yeah, I'm happy to answer them. Actually, yeah, we have a question now that is, what is the major advantage of this tool over Excel? The major one, and the one that I find it more important, is well, actually, there are two. One of them is that this tool is free. Okay, normally we work in a university, in a company, we can get this Excel for free. We can use that tool. But in case that we don't have access to this tool, OpenRefine is open source code and is free. And the other advantage, or the advantage that I find more important, is that you can reproduce the steps that you have done in the file. because, for example, for Excel, if you remove, let's say that you remove one column or you copy and paste, it's difficult to reproduce these steps. I mean, you need to take note in a text file saying I have done this, then I have done this, etc. Or maybe you can miss one step. With Excel, you can commit more mistakes rather than with this tool. And this tool, the feature is that you can you can take the JSON you can take the JSON script, save that, and then you can reproduce the cleaning in a better way. So this is, I would say that this is the main advantage of. So yeah, I have another comment that is to show how to remove the G, the weight in for example, in Excel, or what I will because well, I'm not sure. The question is to remove that using Open Refine or using Excel to remove the G in the. The thing is, using Excel, yeah, I need to check how to do that, and what I can do is I can send, I can paste the solution in the share path. Ah, yeah, yeah, I see. The problem with the G was in the exactly before with the spreadsheet. What I will do is I will find the solution to that, and I will paste that solution in this in the share path that we have. That is okay. Is yeah, here. I will paste again the link. So what I will do here is I will paste the solution to that in order to remove G from the columns, because okay, it could be done by hand now that we have let's say 10 entries, but if we have 500 or more, it will be more difficult. Okay, so I see that we have finished a little bit earlier than scheduled, but well, that means that we can have a lunch a little bit before, in case that uh, you are uh, you are hungry, or yeah, you want a break. So well, thank you so much for attending today's session, and yes, you can check this afternoon the materials, and if you have any other questions, we can discuss them tomorrow. I see that Ian said that for the problem that Luciana asked about to remove a G, that you can convert text to columns in Excel and choose fixed width, and it will solve the problem. But anyway, yeah, I will. Yeah, thank you for the advice. I will try that later, and I will share my feedback in the short path. And also, please feel free to write questions and to add information to that path, because this will be to share, and this will be for us. This will be like another way of communicating rather than with this chat or the. So yeah, I insist. Yeah, thank you so much, and yeah, we'll see you tomorrow. Have a nice afternoon.